Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving greatest integer function, right? So here we have this problem, that is if the integral that is 1 to 5 e raised to greatest integer of x minus 1 over 2 divided by x plus 1 is equal to log of 2 raised to alpha multiplied by 3 raised to beta, where alpha and beta belongs to the set of real numbers, then we have to find the value of alpha plus beta, right? So now here what we are given, that the value of this integral is equal to log of 2 raised to alpha times 3 raised to beta, right? So what we will do, we'll find the value of this integral, right? So let us first assume this integral as I, and I is from 1 to 5 e raised to the greatest integer of x minus 1 over 2 and divided by x plus 1 dx, right? So we'll find the value of this integral and then we'll compare it with this value, and by comparison we can find out alpha and beta, right? So let us start. Now here we see that our integrand, it involves the greatest integer function. So we have greatest integer of x minus 1 over 2. So here what we will do, we'll first make use of the method of substitution, and then we'll try to break this integral I as a sum of two integrals, right? So let us start. So now let us put u is equal to x minus 1 over 2, right? So x minus 1 over 2 can be taken as u is some other variable, right? So now from here we have 2u is equal to x minus 1, so x is equal to 2u plus 1, right? And if we find dx over du, we have dx over du is equal to 2, and this is dx is equal to 2 du, right? So this value will be utilized over here, right? Okay, now see here the value of x, it varies from 1 to 5, right? So the lower limit is 1 and the upper limit is 5. So when x is 1, then the value of u is 1 minus 1 over 2, so this is 0, right? And when x is 5, u is 5 minus 1 over 2, so this is 4 over 2, that is 2, right? So when x varies from 1 to 5, u varies from 0 to 2, right? So now this integral I can be written as 0 to 2. We can rewrite it as 0 to 2 and e raised to u, because here we have x minus 1 over 2 as u, so we have greatest integer of u, and for x plus 1, for x we can write 2u plus 1 and plus 1, right? And for dx we have 2 du, right? So now we have 0 to 2, this is e raised to greatest integer of u, and this is 2u plus 2, and here we have 2 du, and if we take 2 common from 2u plus 2, this 2 and this 2 get cancelled, and now we are left with 0 to 2 e raised to greatest integer of u over u plus 1, right? So now we have to evaluate this integral, right? So now in order to evaluate this integral, we'll break this integral as a sum of two integrals. So now here we see that the limits of integration varies from 0 to 2, right? And here our greatest integer function is involved, right? So it implies that we have to search for the integer which lies between 0 and 2, and we know that 1, it lies between 0 and 2, right? So the limit 0 to 2 can now be written as 0 to 1 and 1 to 2, right? So this integral I can now be written as 0 to 1 e raised to greatest integer of u over u plus 1, and the second integral is from 1 to 2 e raised to greatest integer of u over u plus 1 du, right? So what we have done, we have split this integral as a sum of two integrals, right? So this is I1 and this is I2. So now let us apply the definition of greatest integer function over here, right? See here, u varies from 0 to 1, that is u is greater than or equal to 0 but less than 1, and here u varies from 1 to 2, right? So when u lies between 0 and 1, then the value of greatest integer of u is obviously equal to 0, right? And when u varies from 1 to 2, that is u lies between 1 and 2, then the value of greatest integer of u is equal to 1, right? So here we have 0 and here we have 1, so now I can be written as 0 to 1 e raised to 0 divided by u plus 1 du, and here we have 1 to 2, then e raised to 1 and u plus 1 du, right? So now we have these two simple integrals. So now we know that e raised to 0 is 1, and here I can be written as 0 to 1 and we have du over u plus 1, right? So e raised to 0 is 1. And similarly here we have 1 to 2, e raised to 1 is e is the exponential number, and we have du over u plus 1, right? So now we have two simple integrals, and here we can apply the rule dx over x plus 1, that is the integral of 1 over x plus 1 is log of x plus 1, right? So now I is equal to log of u plus 1, and the limits of integration are from 0 to 1, and here we have e, and the integral of 1 over u plus 1 is log of u plus 1, and the limits are from 1 to 2, right? So now we can substitute the limits and we'll take the difference. So we have log of, here we have u is 1, so 1 plus 1 2, minus log of 0 plus 1, so this is 1, and here we have e, 2 plus 1 3, and here we have 1 plus 1 2, so this is log of 2, right? And log of 1 is 0, so we can ignore it. So we have log of 2, this is 0, and here we have e log 3 minus e log 2, right? And we can take these two terms, so we have 1 minus e log 2 plus e log 3, right? And this expression can also be written as log of 2 raised to 1 minus e, and here we have log of 3 raised to e, right? So here we have used this property, that is log of a raised to b is b log a, right? So now we have this expression, and this expression can further be written as log of 2 raised to 1 minus e times 3 raised to e, because again we have used the result, that is log of the product of a and b is equal to log of a plus log of b, right? So now viewers, we see that the value of this integral I, it comes out to be log of 2 raised to 1 minus e times 3 raised to e, right? And we are given that this value is equal to this one, right? that is log of 2 raised to alpha times 3 raised to beta. Now if we compare both these expressions, we get alpha is equal to 1 minus e and beta is equal to e, right? And remember, e is the exponential number, right? And we have to find the value of alpha plus beta. So alpha plus beta is 1 minus e plus e, and these two get cancelled and we are left with 1, right? So the value of alpha plus beta is 1 and e is the exponential number, and alpha and beta are obviously belong to the set of real numbers, right? So this is how we solve this problem.